the neural network. We have many models in the machine learning, like linear regressions, logistic regressions. This is a tree neural network, and many others. But today we are going to talk about the neural networks. Why is it important and useful in our presentations with the machine learning? And my team are going to explain more into details about this. But today I'm going to present to you a very simple demo of the machine learning. For this machine learning, we are using the supervised learning. We are going to talk more into depth about what is the type of the machine learning. There are main three important types of machine learning. We have supervised learning, unsupervised learning, and reinforcement learning. So today, for this demo, cat and dog, I'm going to introduce you the supervised learning, how to differentiate between the cat and dog. Okay. So here is the picture of the dog, and the other one, the cat. Yes, the cat already. So we have an application that we allow you to upload the image of the cat or the dog, and the application is going to tell you that it is cat or dog. Okay, so as you can see, when we submit and upload the cat, you can see the alert about the cat, and we submit the dog, it can show you the dog. Sorry for the presentation, it doesn't look good, but we just try to make it work because we don't have much time for that. Okay. As you can see, it is not hard-coded. You can see it is very simple, just tell you cat and dog. But the presentation is very simple, but the processing is not. Because we go through many processes of the machine learning, like gathering data, choosing the data, gathering the data, preparing, and then we do choosing the model. Like this, we use the model neural network for our applications, and also we do the training and then do the evaluation. If something we meet the output that doesn't meet our requirement, we are going to do another iteration until we meet our depth, and then we can classify it and make the output like this. So the process is a lot, and my team are going to present more and talk more into details about each process. And today we are going to talk about neural network. Thank you.
Hello, my name is Say, and a lot of people, so give me a few minutes to digest the people. Okay, like you say, we have the demo about the cat and dog, and we use the existing library from TensorFlow, and then we are supposed to classify the cat and dog. So it's simply application that we can create it very quickly. So now let's talk about the human learning and machine learning. So what is the difference between human learning and machine learning? As you can see in the picture, we see a beautiful lady in the classroom, and is teaching their students. So okay, so and in this picture, you will see the cute machine teacher is teaching their machine student. So is that called machine learning? No, so it's not called machine learning. So what is the machine learning? So what is the main difference between machine learning and human learning? Humans learn from the past experiences, while the machine, we need to tell them what to do. They need to be programmed. They follow the instruction. So how to make machine to learn like a human, to learn from the experiences? So yes, the answer is yes. We can make a machine to learn from the past experience. Yes. Now, let's say we want to create a simple Bitcoin price predictor, and now I just gather the data from the Bitcoin.com that is the past data from the bitcoin.com, and we can see the price, and at the x-axis we can see the data from the January to November in 2017. So the question is, can we predict the Bitcoin price in December? Okay, so I take a few data from the Bitcoin. So the first, the data point, the x-axis is the date of the date of the price of Bitcoin, and the y-axis is the price of the Bitcoin in dollars. But to make it calculable, I try to make the date to become a number. So the 100 is represent as the January, and 200 represent as the February, and so on. So now, can we predict something like we input the date of December and they output something, the predicting price on December. So it's equal to 1,200. So if you see the line, if you see the green points, it's almost formed as a line. So if you draw a line like this, if you draw a line like this, so now we are able to predict the price on December. The Bitcoin is 5,616. So this example is not a very good predictor for the Bitcoin. So please don't take this predictor to predict for investment Bitcoin. Yeah. Because we need some more knowledge about it, and we need to upgrade this algorithm. Because in this algorithm, we just use the linear regression, so we can use the multi-variable regression to make this predictor more accuracy. So now we can predict Bitcoin in December. So you will ask me, how can I find this line? Okay, so next one. So example, I have those 3 points, and I draw a random line. And how can I know that line is the good for this data? So assuming I calculate the error. So the error, you can see the point from the line to the point from the line to the point. So we have the distance about it, and we try to take all these errors and sum it together and see how much error we have. Okay, now we try moving the line a little bit to another direction, and we measure again for the error, and we can see that we can reduce the error. So our line is more better. If we keep to do this procedure several times, finally we will get the best fit line for those 3 points, and we will see our errors now we have shorter. So we have a smaller error. So it means that we find a good best fit line for those data points. So let me show you about the graph. So assuming we want to draw a line, so this is the function of the linear regression. So now we don't know which direction we should go. So we try to update it again a little bit and several times until we find a good best fit line. But without the errors, we cannot see that which direction should we go and which way is the best for this solution for this problem. So if we look a little bit down, so I print the error, the sum of the error, so I calculate from the y subtract with what I was predicting. And now we can see the errors. If you see the error, if the error number keep increasing, so we will move in the wrong direction. If we see the error reduce, so we will see that it's more, we move closer to the best solution for us. So, okay, so I see the 5.8 is the best solution for me. me to speak more. Chắc là dân Thái Lan vậy. Chứ dân miên là dân trong vừa bị quan và prediction thôi chứ. Bây giờ dân miên bây dân bữa giờ dân mơ tăng rạp nó dân ai tu lai ngồi. Ta dân ở đâm thà lai ngồi ná đại viên là o chúng ngồi nằm rò là bao nhiêu này. Chứ nằm bây bỏ lai nè, chứ dân miên ôi thì họ vậy. Chứ dân miên lai dân miên để tạm quan vậy ôi thì họ. Chứ mà xin viên ai vừa ca viên ai khổ lại ao dương ba này chứ đặc biệt ao viên ta khổ lại chứ ao dương bán lutra thì dương viên random line hay viên mùi chứ ưu tiên họ thay viên random line phải này chứ thứ mấy thà đâm thà táo line ao dương nó viên o được phu dương chứ cái bị thi mùi tại cái ai kẹn này đâm thà line nó chỉ solution lo ao dương đó cứ cái kẹn này eo rồi chứ eo đó cứ nhân vô chùm nói này line ní mùi năng để ta point để ta point đại dân đại chia vì sao chứ dân tỏ nó dân ban vào bài này hay dân kẹn địa thay tiền chứ dân ban đọc cái dân sang bia chỉ mỗi cái này tới dân bô vi chỉ mỗi cái này tới dân ban lai vào bài này chứ dân mua vi tiền chứ nó có viên tới dân ai chờ kẹp đi ăn mua từ hàng ngày chứ tỏ viên tay mơ sần chứ dân miên ao viên vừa cam đo tiền chứ ưu tiên họ thay dân biết vừa cam đo tiền hay cái mua direction offline đó ao biết áp một tí chứ nó bây đại dân đọc bây dân mơ tới dân khơi thang dân cái ảnh địa error nó môi tiếp dân khơi thang line đó chắc là đang lời chân một chứ khi là dân bố quay trô ní dân khơi line đó lời chân một chứ viên đó viên chia solution đại oi phổ biết viên man ở các thói error này chứ ưu tiên họ thang dân vừa sẽ càng khiên tân tận đại chờ đó là hôn đo dân khổ khơi best fit line mùi đại chia đại viên đôi chỉ một đại viết chỉ line với đại lõ nó không problem bao nhiêu này chấm line đại lõ nó không problem bao nhiêu này cứ line đại viết error tu bằng phật nhưng đôi dân số nó không làm mình chắc nhưng tôi bây giờ dân mua line cho làm chấm dân chỉ dân hộ về nó cứ cái con rạp từ này chấm nó bây giờ mấy con rạp từ nó dân chỉ dân hộ mấy con rạp từ mùi nát đây lõ chỉ mùi solution đại lõ chỉ mùi nó problem bao nhiêu này chứ nó bây đại dân hộ khơi nói nâng hái gương chia best fit line của dân chân dùng sam rì làm với chân linear regression dân miền đề tán x rồi có bây dân research tới dân ai khơi miền x dân hai thay input dân trở thành dân thay input rồi có dân hai thay feature y cứ chỉ output chân đi cứ chỉ function for linear regression chân dân miền weight tung cho môi là x cứ chỉ data bao nhiêu này thử đặt chỗ bột cho môi bài á năng hết cứ chỉ ăn được sao bao giờ chắc nhưng mà đi chỉ mấy con rap tức chắc solution bao nhiêu cứ những thử cá ổ vây đại lọ chứ nằm bây học vây đại lọ những thử calculate error rồi có cái hai tháng top function rồi còn mà dạng tiếp cái hai tháng square error hay đấy mà cái hai tháng square error before
so can you go to the next slide? Thank you. So I was saying that we are going to go through the training process into the neural network algorithm. So you can. So this is a schema of a small neural network. So you can see there is one node to input the weight of the fruit, and one node to input the size of the fruit, and we have one node to have the output. We have two different parameters we can learn. Is weight number 1 and weight number 2. So this parameter helps us to create the function that will take a fruit weight and size of the fruit and output the type of fruit, so watermelon or apple. So you can go to the next one. So as every problem we have in machine learning are not as simple as size and weight of a fruit and output the type of fruit. We need to have more parameters we can learn about. So it's why we can introduce a new layer, the hidden layer. So we didn't speak about that before, but the first layer is called input layer, and the last one is output layer. the purpose of the input layer is to input your data. So if it's an image, you are going to input some pixel value, is what you can see there. So let's say we have an image as an input, so we are going to input each pixel of the image and try to output the correct class. So either a watermelon or apple. Or if you want to classify dogs and cats, it will be cats and dogs. Okay. So as we introduced the hidden layer, we increase the number of arrows. Each arrow represents a weight. A weight is just a learnable parameter. It's a parameter that will evolve through the time and through the training process. So as we have more weights, so it's easier to find a good function and to approximate this function. So it's easier to learn about this. But the more weight we are, the more architecture. If the architecture is really big, it means that the calculation will be big and the time of computation will be big too. So we need to find a good balance between too much weights, so too much training, and too less weights, so we will not be able to classify correctly the input. So I'm going to let Paul speak about the following.
Okay, so what have we learned so far? Yeah, what have we learned so far? So machine learning takes a lot of data to work. The more data, the better. The purpose of the training is to update your learnable parameter, which are called weight. Without the weight, you cannot predict anything, and your machine learning algorithm cannot learn. Everything comes from the weights. And one data from your data set will be equal to one prediction from your neural network. So one data input in your neural network will result into an update of the weight. So here is a simple example of the classification of an image given to class. So either it's a cat or a dog. Here at the first iteration, so the first time we enter our neural network with data, we can see that the values are kind of random. It's normal, because the first time we go into our neural network, the weights are not predicted, they are just random. And when we will input more data, so when we will go through more iteration, the weight will become more accurate, so will be our answer. So as you can see, at the iteration 2 already, the prediction is more accurate than before. At the first iteration, you can see that it's like 20% of accuracy for a cat and 70% for a dog. At the second iteration, it's 40 and 50%. At iteration n, so it's a parameter you will give to your neural network as how many times do I need to go through my neural network with my data. So you can see that everything is more accurate, as it is an image of a cat. The prediction of cat is way higher than the one of the dog. So the classification is a little bit different from the training part. The classification comes after the training part, and it uses the weights we trained to classify new data. So data that is not in our data set. It is used in production, so it's really what you will use if you want to sell a product. You really don't want to train every time your neural network if you want to predict a new value. This is a simple schema of the machine learning cycle. So the first step will be to set up your data set. So what is my data? What is my problem? And how will I resolve it with my data? Then you want to transform the data. Kevin spoke about the feature extraction. So it's there. It's how will you change your data. It's how will you change your data to be able to put it into your neural network. Then you need to choose a machine learning algorithm. Each problem has its best machine learning algorithm. Next, you need to train. So the training process is your algorithm will learn from what you give to it. So it's really here that you will define your neural network. You need next to evaluate it. In most of the software, you need test suite. It's kind of the same thing. You need to see how good your neural network is at resolving new questions. If your neural network is already good enough, then you've got your neural network and you can use it in classification in production. If it's not good, the first thing you can do is tune your hyperparameters, which we will talk about a little bit later. And each machine learning algorithm does not have the same hyperparameter. Here we will talk about the neural network ones. What you can do also is to change your data set. Your data really mold your neural network into something. So if you change your data, you will mold it into another thing. And the next thing you can do is obviously change your algorithm to solve your problem.
Okay, so now we are going to speak about hyperparameter tuning. So how you going to get your model to be better at classification? So you have in neural network you have four different hyperparameters. The first one is the number of iterations, also called as epochs, but I will go back on this one next. The alpha, so it's also called learning rate or speed of the neural network to learn. And the last one is the size of the neural network. So if it's big or small, if there is few hidden layers, just one hidden layer or no hidden layers. So about epochs, what is epochs? It's the number of times you're going to input your data in your neural network and then update your weights. So it's the number of times you're going to learn about your data. So if the number of iterations is small, obviously the time of training will be small, and if the number of iterations is big, your training will be really long to finish. So about alpha. So alpha is how much you're going to update your weights in a training iteration. So you have this formula. Okay, you have this formula, it's weight plus equal to the update times the alpha. So the update is something we are going to calculate in an iteration to see how we need to update our weight to be better. So sometimes we need to increase the value of the weights, sometimes we need to decrease them. So this value told us how much we need to increase or how much we need to decrease them. But we don't want to update too much the weight, so we are going to use the alpha to help us to control how we are going to update the weights. So this slide is about a good configuration of neural network. So you can see that the curve is going. Okay, sorry. So you can see that the curve is going down, and we need this value, the error rate. So the error rate indicates for us how well we trained on this iteration. We need this value to be low as possible. So here we have like 45 seconds of training. That is really small, like it's really fast. So we need to have fast training, but accurate training. So we need to optimize those parameters to get fast and well-trained model. So this configuration is not the perfect one, either for this problem or another one. So don't take this value as perfect. It's just an example on one specific problem we solved with machine learning. So we are going to see how we can see which parameter we need to update and how we need to update them. So next slide. Okay, so here we have a small network. What does it mean? It means that we don't have so much learnable parameters, so not so much weights. So here we have just one hidden layer with one node. So as you can see, the model begins to really go down at the according to the error rate, but it can't go through a specific error rate. So we need to increase the number of learnable parameters to be able to really solve this problem. So next one. So here we can see that the error rate is quite low at the end of the training, but as you can see, the time we train it is 25 minutes. 25 minutes is big for this problem, it's too much. So we need to decrease the number of nodes and the number of layers to be able to solve this problem, but not taking too much time. Next. So here we have a low alpha, so it means that we update really slowly the weights. So here we can see that the curve is linear and it's not going down really fast. So we need this curve to be really down. We want the error rate to be low at the end of the training. So next one. Here we can see that the error rate is too high, so we update too much our weights at each iteration, and it's really bad. We need to balance this value. Each hyperparameter needs to be balanced for the problem. Okay. To summarize, the training process is optimizing the weights to be able to classify your data in a correct way. So, and then the classification is the part you're going to use in your application. So if I train a model to classify dogs and cats, I want to use this model at the end, so all of these trained weights to be able to classify new input from my new user. And better the training, better will be the classification, so better will be your application. So we are going to speak about two different libraries. There is a really big number of libraries in Python and in different language of programming language. So Paul is going to speak about TFLong.
So first, what you need to know is almost every program in machine learning is written first in Python, because it's really where you have the most machine learning libraries. Here I'm going to present you really briefly TFLong, which is based on TensorFlow. TensorFlow is also another deep learning library, but it is much more harder to get in hand in the first place. So here it's really easily to get in hand, and it's really good for beginners. You can have really fast results with not much line of code, and you have a huge documentation. What is not that great with this library is that there is a small community, because everyone starts as a beginner, but they evolve fast, so they move on to another library as TensorFlow. And another cons is the huge documentation. If you do not really know what you are searching for, you will get lost in the documentation.
So I'm going to speak about the PyTorch library. It's a deep learning and neural network library. And what is good about PyTorch is that it implements a lot of different algorithms, machine learning. It's easily debuggable, so if you compare to TensorFlow, if you compare to TensorFlow, it's so much easier to debug. Sorry. As the project of PyTorch is really new, there is not so much people involved in the project, but the project is going really up, and people are really happy about this library. And also Facebook is going to
machine learning algorithm. Sorry for the noise. So we are going to show the demo. Okay. Next one. This one. Next one. Okay. So we built another front end just to show you how it works because it was messy in the terminal. So, well, you already can see some values and everything. We text classified English, which is easier than Khmer language, because in English the words are already split. In Khmer it's kind of different, so we use the software to split it. So we can show you, we have a few classes. They are all written here. So we have time, price, goodbye, thank you, hello. Like basic classes for another project we built. So here is a small example. So we put hello, we submit it, and we talk to our Python script, which will respond. So here what you can see is probabilities. Everything in neural network is probability. So it's a guess from the neural network. Here the neural network guesses that the word hello is 99% in the category greetings. And it will be the same thing for every sentence or word you input. We can try another thing. So here is how long does it take? Something like that. And you will see that the category it will be in will change with another probabilities. So it's really not matching sentences with another. It's not classic comparison of strings or sentences. It's really you train your neural network on a data set, and then it will try to guess your new input. So, well, we could try this for other sentences in English before going to Khmer. So I don't know, how are you, or just say goodbye, see you soon, something like that. Then we will go to Khmer. Khmer language, as I say, is a little bit more difficult to train because you need to go through a software to split the words. You cannot just input the sentences. The neural network will not find anything to feed it. So here, well, I can't read Khmer, but most of you can. And I think this is Tuesday, and well, it categorizes it well in greetings. So it's exactly the same principle as in English. The only thing that changes from English to Khmer is really the way you process your input. So, but everything else is different. The neural network and the backend, frontend, everything is the same for both of the sentence classification. Okay, so another example. As it's harder to train Khmer language, the accuracy is dropping compared to English. In English, I think we hit like 95% of accuracy, but in Khmer we have like 75 or 80% of accuracy. We can go back to the slides, or just an example. Okay. So here, I think Macaroni is going to explain how the visa chatbot is working.
Okay, and I'm planning from the mind that That tôi chỉ muốn nâng application của machine learning của YouTube của bạn thì that tôi để một mỗi that tôi chỉ muốn nâng visa chatbot. Visa chatbot nó cứ dùng của chatbot mỗi that tôi xu chỉ muốn nâng visa. That tôi chỉ muốn demo củaយើងបច្ចុប្បន្នគឺមានត្រឹមតែអូស្ត្រាលីជាមួយខ្មែរតែយើងអាចមានផ្សេងៗច្រើនទៀតនៅពេលក្រោយយើងទៅភាសាពីយើងកំណត់យើងមានអាច train data set តាមតែចំនួនសញ្ញាតាខ្មែរនិងអូស្ត្រាលីតែពេលយើងចង់ទៅប្រទេសផ្សេងៗទៀតយើងអាចទៅពួកយើងជាមួយនឹង data set ដែលយើងមានច្រើនទៀត Okay, please. Okay, ក្នុងកំឡុងពេលពួកdemo នេះខ្ញុំសូម update ខាងមុខតិចដោយសារតាមមិញយើងឃើញថាពេលយើង trend ដែលតាមយើងជាសំវិញគឺយើងលឿនខ្មែររបស់យើងយឺតដោយសារពេលយើងវាយហ្នឹងគឺខ្ញុំមានបាយស្បែកហ្នឹងអញ្ចឹងរបស់យើងគឺយើងត្រូវធ្វើ segmentation ខ្មែរយើងកាត់អស់ទៅតាមន័យរបស់វាទៀតអញ្ចឹងកន្លែងហ្នឹងវាធ្វើឲ្យ take time ជាយូរតែដល់ segmentation គឺយើងអត់បានធ្វើខ្លួនឯងដែរដោយសារនេះយើងត្រូវ library របស់យើងតែកន្លែងនេះគឺយើងសារដល់តែធ្វើ segmentation ហ្នឹងផងយើងអាចធ្វើតែគាត់បើសិនជាអាចកាត់ផងគឺបានលឿនជាងតិចតែដល់ real time អូខេចូលមកដល់នេះខ្ញុំមកក៏បាយដល់ចំណុចគូសោះchemical ចូលតាមថងមួយអូខេដំបូងខ្ញុំវាយវិធី hello ដើម្បីសួរវាដល់ប្រើជាភាសាអង់គ្លេសតែសាប់មកយើងអត់ទេអញ្ចឹងគាត់ឆ្លងទៅវិញអូតូគាត់ដឹងថាអានេះតែต้องជាមួយនឹង machine learning training and classification ពេលគាត់វាយពី hello មកគាត់អាចដឹងថា classify វាថាវាស្ថិតក្នុងប្រភេទ category rating អញ្ចឹងយើងមាន database នៃ answer ដែលត្រូវឆ្លើយជាមួយនឹង rating របស់យើងអញ្ចឹងអានេះគឺជា answer របស់យើងដែលយើងឆ្លើយ React now យើងចង់សួរពីសុខសប្បាយគាត់នេះអញ្ចឹងពេលគាត់ឆ្លើយវិញគឺគាត់សួរថាយើងធ្វើការយើងសួរថា what can you do យើងសួរថាគាត់អាចធ្វើអីបានខ្លះអញ្ចឹងគាត់ថា first គាត់នឹងថាតើគាត់មាន function ស្អីគេគាត់គឺធ្វើអីគេអញ្ចឹងអានេះគឺរាល់ input sentence ទាំងអស់គឺយើងធ្វើការ classify រាល់ input ប៉ុន្តែយើងមាន database របស់យើងដែលយើង input គួរសមដែរតែมันទៅច្រើនដែរបងមកយល់ថា sentence មួយនេះគឺចង់និយាយពីអីប៉ុន្តែក្នុង training data របស់យើងអត់បញ្ចូលពាក្យហ្នឹងហ្មងទេគឺយើងបញ្ចូលពាក្យផ្សេងគ្នាច្រើនដែលនៅពេលដែលមានពាក្យណាផ្សេងจาก data set របស់យើងគឺយើងអាចធ្វើការ analyze ហើយ train ឲ្យបានយល់អត់ចឹងទាំងអស់នេះមិនមែនមាននៅក្នុង database ឬ data set ដែលយើងមានស្រាប់ទេគឺសិតតែយើងវាយផ្សេង copy អ្វីដែលយើង train អស់ចឹង training data គឺ different from this one ណាអូខេបន្តមកទៀតសួរថា where is the process embassy យើងចង់សួរថាបើថា Lisa ក៏ប្រាប់ថាគាត់មកជំនាញរបស់គាត់គឺនិយាយពី location របស់ embassy និយាយពី location របស់ស្ថានទូតហើយអញ្ចឹងយើងសួរទៀតថា claim មកគឺឈ្មោះគាត់សួរថាតើ embassy ដែលនៅជិតជាងគេគាត់គឺនៅណាអញ្ចឹងយើងអាចសួរពេលដែលchatbot របស់យើងឃើញមួយ sentence នេះអាច analyze ដឹងថាគឺចង់សួរពី embassies when embassies which category of classification របស់យើងទៅវិញចឹងពេលដែលនេះគាត់ក៏សួរបន្តទៀតថាតើយើងចង់ travel ទៅណាខ្លីមកគាត់ក៏ដាក់ថាគាត់ចង់ទៅអូស្ត្រាលីតែទៅអូស្ត្រាលី visa ក៏ត្រូវសួរទៀតដែរថាបើអ្នកចង់ទៅអូស្ត្រាលីតើអ្នកឯងមានប្រភពចេញមកពីប្រទេសណាជាការយើងចង់ apply visa ទៅអូស្ត្រាលីយើងមកពីអឺរ៉ុបមកពីអាស៊ីឬមួយក៏យើងមកពីជប៉ុនឬក៏កូរ៉េអញ្ចឹងទៅត្រូវដឹងថា location ព្រោះយើងត្រូវដឹងថាពីកម្ពុជាទៅអូស្ត្រាលីត្រូវចំណាយម៉ោងប៉ុន្មានពីជប៉ុនទៅអូស្ត្រាលីត្រូវចំណាយម៉ោងពីកូរ៉េទៅអូស្ត្រាលីចំណាយម៉ោងពីអឺរ៉ុបទៅអូស្ត្រាលីចំណាយម៉ោងអញ្ចឹងយើងក៏ត្រូវដឹងពី destination ហើយនឹងដឹងអំពី source របស់គាត់ដែរចានេះ destination របស់គាត់ចង់បាន visa នៅប្រទេសអូស្ត្រាលីប៉ុន្តែយើងមកពីណាគឺមកពីប្រទេសកម្ពុជាអញ្ចឹងវាប្រាប់ថាកន្លែង embassy ដែលនៅជិតអ្នកបំផុតហ្នឹងគឺអ្នកអាចទៅរក embassy របស់ប្រទេសអូស្ត្រាលីហ្នឹងគឺមាននៅផ្លូវអាស័យដ្ឋានលោកក្រម16ពេលស្អីសង្កាត់ឬភាសាខាងតាមមួយបន្តមកយើងសួរថាចុងក្រោយយើងសួរថាតម្លៃរបស់ភាសាប៉ុន្មានតើតើមួយនឹង training set វាដឹងថាយើងនឹងសួរតើតើមួយ classification យើងដឹងថាវាចង់សួរយើងចង់សួរពី price របស់ visa ពីប្រទេសកម្ពុជា apply visa ទៅអូស្ត្រាលីការចំណាយអស់តម្លៃប៉ុន្មាននេះគឺសិតតែស្ថិតនៅក្នុង classification and training ដែលតាមបន្តមកទៀតគឺសួរព្រោះ visa មានប្រភេទច្រើនមានប្រភេទសម្រាប់ business sub holiday ហើយនិង business ហើយនិងsorry សម្រាប់រស់នៅអចិន្ត្រៃយ៍តែម្ដងអញ្ចឹងពេលដែលយើងរើសយក business ចុងក្រោយគាត់ពិសួរថាតើយើងអាយុប្រហែលព្រោះតម្លៃ visa គឺវាផ្សេងគ្នាសម្រាប់អ្នកអាយុច្រើនតម្លៃផ្សេងអ្នកអាយុតិចតម្លៃផ្សេងហើយប្រភេទ business ក៏ដូចគ្នាដែរចង់ទៅធ្វើ business ចំណាយមក អូខេពេលខ្ញុំវាយ input ឈ្មោះរបស់ខ្ញុំមកគឺ chatbot របស់យើង list information ដែលតាក់ទងជាមួយនឹង business ទាំងអស់ដោយសារតែខ្ញុំជឿថាខ្ញុំទៅនឹងដើម្បីធ្វើ business អញ្ចឹងនៅក្នុងនេះមានតម្លៃផ្សេងៗគ្នាសម្រាប់ធ្វើ business talent ហើយនិង innovation ទៅដាក់ទុនពីដូចអីគឺត្រូវចំណាយវាយវាសាមញ្ញណាស់ហើយនឹងអ្នកដែលជាម្ចាស់របស់ business តែម្ដងតែគាត់ត្រូវចំណាយប្រហែលសម្រាប់ដុល្លារ ចឹងទាំងអស់នេះគឺតកតងជាមួយ chatbot visa